The idea of a Dyson sphere is one of the most famous images in science fiction, a solid shell completely surrounding a star, capturing all its energy. It looks elegant, it looks inevitable, and it is physically impossible, not because we lack technology, but because gravity and mechanics forbid it. If a Dyson sphere ever exists, it will not be a shell. It will be a swarm. Let's start with the simplest issue. Strength. A solid shell around a star would be unimaginably large, larger than any planet. Every part of that shell would feel the star's gravity pulling inward. That means the structure must support its own weight in compression. At small scales, materials can handle compression. At planetary scales, they cannot. This is the same reason you can't build a hollow planet, a rigid planet-sized dome, or a solid shell around Earth. The stress at the base grows faster than material strength. Eventually, atomic bonds give way. No known material like steel, diamond, graphene, or any hypothetical supermetal can survive compressive stress at stellar scale. This isn't an engineering gap, it's an atomic limit. Even if you imagine an impossible material, a Dyson shell fails immediately for another reason: instability. Inside a hollow spherical shell, gravity cancels out perfectly. That means the star at the center experiences no restoring force. If the star moves even slightly off-center due to radiation pressure, internal stellar motion, or gravitational nudges, nothing pulls it back. Instead, the star accelerates toward the shell. The imbalance grows. The shell doesn't self-correct. It catastrophically fails. This isn't a subtle effect, it's a fundamental result of Newtonian gravity. A Dyson shell has no stable equilibrium. There's another fatal issue. Orbits only work because objects are in free fall. Different orbital distances require different orbital speeds. A rigid shell can't do that. The inner side wants one velocity, the outer side wants another. The structure cannot satisfy both simultaneously. So the shell can't orbit, it can't hover, it can't passively exist. To stay in place, it would need continuous active support, perfect control, everywhere energy flows larger than what it's trying to collect. At that point, the shell defeats its own purpose. A Dyson swarm solves every one of these problems. Instead of one rigid structure, you build millions or billions of independent satellites, each in its own stable orbit. Each element experiences manageable forces and requires no global structural support. It can adjust its orbit individually and doesn't transmit stress across planetary scales. If one unit fails, the rest continue. Construction can happen gradually over centuries. No single point of failure exists. This obeys gravity, orbital mechanics, material limits. That's why real scientific discussions never talk about Dyson shells, only Dyson swarms, clouds, or rings. The reason Dyson spheres must be swarms isn't pessimism, it's physics. Rigid planet-scale structures collapse under gravity. Shells are unstable, materials have limits. But distributed orbital systems? Those work. So if we ever detect a star dimmed by artificial structures, it won't be wrapped in a shell. It will be surrounded by countless moving parts, a civilization-sized choreography in orbit. Gravity doesn't allow monuments, it allows motion.